Hey everyone, Math 6 9.4 video. Today we're talking about measures of variation. First measure of variation we're going to talk about is range. And range is really simple. It's just the distance between the smallest and the largest pieces of data in a data set. So we're going to calculate the range here. Okay, so the following data set gives the different ages of people who visit the K1 speed go-kart racing. Okay, and we're going to calculate the range of those ages. So all you have to do is identify the smallest, okay, and the largest. And we're going to take the largest minus the smallest, and that equals the range. So we've kind of developed a little formula here. Okay, so what's our largest piece of data? So we got these different ages of folks: 10, 22, 56. Yeah, ooh, 96. That is the oldest person who visited. Maybe this was taken within, an hour. Smallest, let's see, you got some pretty young folks, but it looks like 10 is the youngest, okay? So what is the range? It's just 96 minus 10. 86. So there's a range of 86 years between the youngest and the oldest person who visited K1, whenever this data was collected. 86. Easy as that. All right, so next we're going to talk about quartiles, okay? Now, what's a quartile? Well, it divides a data set into 4 equal parts. And another little thing to know is that the median, which we've been dealing with already, is actually called the second quartile, okay? So we're going to take these one at a time, but I gave us a data set here that we're going to reference for the different quartiles we're about to talk about. All right, so the second quartile, again, the median, same thing. Let's figure that one out first. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces of data, which means the median is going to have 5 on one side and 5 on the other. So that means the median is going to be right there, which actually means we need to calculate it, okay? And I'm going to do a little Q2 there for second quartile, or quartile 2. Or you could say median, median. All right, we need to calculate that. So remember, to calculate a median that is actually not present, we need to find the mean of 28 and 30. And so when you do that, you take 28 plus 30 and you divide it by 2. Well, that's what? That's 58 divided by 2, so it's going to be 29. Okay, so the median, or quartile 2, is going to be 29. So we're kind of going out of order, but now we're going to calculate what's called the first quartile. And the first quartile is going to take this first half of data and break it into 2 separate parts. So we took the whole thing and broke it into 2 parts with the second quartile, and now the first quartile, which is really the one that comes first in the data set, is going to take this first half and it's going to split it in 2. That's easy because this over here, this first half, has 1, 2, 3, 4, 5 pieces of data. So what's the piece of data that breaks it in half? It's that one right there, 22. That's the first quartile, okay? Now let's go to the third quartile, and again, this one's going to be easy. Why? Because in this second half of data, I've got 1, 2, 3, 4, 5. So what breaks that half of data into 2 of its own halves is this one right here. 32. Okay, so now what we see is we've broken it up, this whole entire data set, into 4 equal parts. 1, 2, 3, and 4, right there. And that's what quartiles do. All right, so now let's talk about interquartile range. Okay, so the interquartile range is the difference between the third and first quartiles. And it represents what we call the middle half of all the data in a set of data. So let's calculate the interquartile range here. So again, the difference, so I'm thinking subtraction of the third and the first quartiles. So what we're going to do is take the third quartile, which we said was right there, 32, difference, right? So we're going to subtract what? The first quartile, which was 22, and what is 32 minus 22? The interquartile range is 10, and what that means, again, it's a range, right? So it's telling us that there is some space numerically between the first and the third quartiles, and in this case, it's a space of 10 between the 22 and the 32. All right, so I know it's kind of a lot, but that's okay. You guys are up for the challenge. I want you to try this. I want you to pause the video, calculate the first quartile, the second quartile, which again we just know is the median, and the third quartile of the data set. Then find the interquartile range. See if you can do it. Okay, so what you probably notice is that like up here, this data set was ordered from least to greatest. So we need to do that. So let's reorder that. All right, so I ordered the data from least to greatest. So let's calculate the first quartile, second quartile, and the third quartile. So I think the easiest one to do is start with the second quartile. Okay, so find the median. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so an odd number of pieces of data, so that means we will know the median without having to calculate it. Okay, so it's going to be the 17. That's our quartile 2, or the median. Why? Because if you look at 17, there's 1, 2, 3, 4 pieces of data on his left, and 1, 2, 3, 4 pieces of data on the right. Okay, so that's our median. For the first quartile, again, it's what splits the first half in half. Okay, so here's our first half, right? We don't include the quartile here, the second quartile, so it's these 4 pieces of data. So what we need to do is figure out where's the median here. Well, the problem is the median's going to lie between the 9 and the 12, right? Okay, so to find the quartile there, I've got to, go ahead and do that. All right, so let's calculate the median of 9 and 12. So what we're going to do there, we're going to do the 9 plus the 12. We're going to divide that by 2. So we're calculating the median here, the first quartile, by doing the mean of the middle 2, right? So 9 and 12 gives you what? Okay, 21 divided by 2 is going to be 10.5. So I'm going to put a little like arrow there. How about this? Just do a line of 10.5, and that is quartile 1. And then we'll come over here and do the same kind of thing. So here's our second quartile. So now we're looking at this upper half of data, the 18, 20, 23, and 24. And we again need to calculate the quartile. So we're going to take these 4 pieces of data and figure out what's right in between. So since it's an even number of pieces of data we're looking at here, I need to find the middle. Well, it's going to be between the 20 and the 23, right? So how do I find that? You got to find the mean. So let's take our 20 plus our 23 and divide that by 2. So that gives you 43 divided by 2. And when you do 43 divided by 2, what do you get? 21 and a half, okay? Because that's, again, 43 divided by 2, 21 and a half. Just dividing, okay? You guys know how to divide. Not worried about that. Or 21.5. That's quartile 3, and that's going to lie right there. All right, so lastly, we need to calculate the interquartile range. And again, how do you do that? Well, remember, interquartile range is quartile 3 minus quartile 1. It's that easy. So what's our quartile 3? It is 21.5. We're going to subtract the 10.5, which was our first quartile. Okay, and when you do that, 21.5 minus 10.5, well, let's see, minus 10, we get you, okay, 11.5, and so then another one. Okay, so it's 11. That is your interquartile range. Your IQR is 11. All right, so just look at this dot plot for a sec. What jumps out? Or hopefully, you look at this and you go, oh my goodness, that looks like an outlier, okay? And you might be right. Now, this is just a sketch, but we actually have a way now to calculate if a piece of data actually is an outlier. And it's not just by looking at it, we can actually run a calculation. So here we go. All right, so bear with me on this. Take a breath, focus, we're going to get through this. Okay, this is a little complex, but I want you to see it. All right, so again, we're trying to figure out, okay, is there a way to know if there's actually an outlier? Like maybe a piece of data looks like it's an outlier, but is it actually? And that's what we're figuring out. So, when we look at a data set, we have low outliers and high outliers, right? Okay, so like in this data set here, if I had a dot plot, and I drew some dots in like this, and we got a lot of dots, like this, and this, and this, and this, and then I've got this one, like, random one right there. That would be like a low outlier, okay? Versus here, I would have, maybe have a bunch of data right there, okay? And then, there, something like that. And then I got this one, random one right there. That would be a high outlier, or at least it would look like it. So let's talk about the low ones first, the ones that are going to be, like, on the left side. Okay, so what's a low outlier? Well, it's anything that's less than the first quartile minus 1.5 times the interquartile range. Okay, so let's use that last data set we were working with. Okay, so let's figure out what the low outlier should be. So anything less than our first quartile minus 1.5 times the interquartile range. So what was our interquartile range from up there? It was 11, right? Okay, so 11. The IQR was equal to 11. So let's use that. Anything less than quartile 1 minus 1.5 times the interquartile range of 11. So what was our first quartile here? Well, it was 10.5. So let's do 10.5 minus 1.5 times our interquartile range, which from that data set we were previously working with was 11. Okay, so what's 1.5 times 11? Well, if you do 1.5 times 11, you have 1 times 11 plus a half times 11, and that gets you what? 16.5. Okay, so let's do 10.5 minus that of 16.5. So it's 10.5 minus 16.5. You end up getting negative 6. Okay, so the low outliers for this data set is going to be anything less than negative 6. Okay, so let's look here at our data set. 7, 9. Okay, so the outliers would be on this side of the first quartile, and they would have to be less than negative 6. Well, are these less than negative 6? No. So we don't have any outliers this way. Now let's talk about the high outliers. That's going to be almost identical to this, except that it's anything greater than the third quartile plus 1.5 times the interquartile range. So what was our third quartile? We said it was 21.5. And now we're going to add 1.5 times the interquartile range, which again was 11. Okay, so what's 1.5 times 11? Well, take your 11 times 1 is 11. Half of 11 is 5.5. And so what do you get? 16.5. And then we're going to add that to our third quartile, which again was 21.5. Okay, and when you do that, and you get 38. Okay, when you add that up. So again, what are high outliers going to be in this data set? Anything greater than 38. So let's look here. Do we have anything greater than 38? No. So in this data set, did we have any outliers at all? Nope. No outliers here. Alright guys, I know this is a tough lesson, especially towards the end. We're going to practice it a bunch more in class. I appreciate you sticking with it. Watch the video one more time if you're still struggling. Come to tutoring if you want. And yeah, we're going to kind of keep plugging away in class. Alright, see ya.